Section 2.4, going back a little bit to circles, but it comes nicely because the next section will be about ellipses. So 2.4 is about circles. A circle is a set of points in the xy plane that are fixed distance r from a fixed point hk. So all a circle is it's a set of points that are equal distance from a center. The fixed distance r is called the radius, so we know that how far away all the points are from the center is called the radius, and the fixed point hk is called the center of the circle. So in an xy plane, we can put a circle, the center, wherever we want, and we can make a radius however big we want as well. An equation of a circle, the distance between points hk, so this is hk is the center, and xy, so whatever point it is in the plane that's on the circle, must always be the radius. So from the distance formula, when we want to find the distance between 2 points, we take the x minus the h, or the x coordinates minus each other, and square them, and then the y coordinates minus each other and square them, and then square root gives us the radius. So if we square both sides, we're going to have the standard form of a circle is this right here, which is the x minus the x coordinate center squared plus y minus the k coordinate center squared is equal to the radius squared. The standard form of a circle is just what we had there. Again, I'll say it again to try to reinforce it. The x minus the x coordinate center squared plus y minus the y coordinate center squared is equal to the radius squared. The standard form with a radius and a center at 0 is just going to be x squared plus y squared is equal to r squared. When you see this right here, this means that the center of the circle is at 0, 0. And then when the radius is equal to 1 and the center is at the origin, or at the center that's at this origin right here, then we have the unit circle. So every point from 0, 0 is exactly 1 unit away. So we have x squared plus y squared is equal to 1. So if we do a little bit of practice with this, finding the center and radius of this circle, the center is at 1, 2. Just looking at the picture. The radius is going to be the same distance from here to any point out here. So if we go from here to this point is 2 high, and this is at 0 high, so the radius, to get from here to here, we'd have to go a distance of 2. The radius in this case is equal to 2. Standard form of the circle, so we're going to have x minus the x coordinate center, which is 1 squared, plus y minus the y center coordinate, which is 2 squared, is equal to the radius squared. The radius is 2, so 2 squared. We can simplify that 2 squared a little bit. We'll go x minus 1 squared plus y minus 2 squared is equal to 4. This right here would be considered the standard form of the equation. In this one, write the standard form of the equation and the general form of the equation. I'm going to hold off for a little bit with the general form of the equation. So we're going to skip that for right now, but we're going to look at the standard form of the equation of a circle of radius r and center hk. Graph the circle. So here, our center is at 1, 0. The standard form, we're going to have x minus the x coordinate center, which is 1 squared, plus y minus the y coordinate center, which is 0 squared, is equal to the radius squared, which is 3 squared. If we do some simplification here, x minus 1 squared plus y minus 0 is just y squared is equal to 9. So here we have the standard form of the equation. If we're going to graph this circle, when we graph this circle, we have a center at 1, 0. So 1, 0 is our center. From there, all the points are 3 away, so we'd go 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So once we have those points, we can connect those dots, and there we have the equation, or the graph of our circle. So how is this going to work on MyMathLab? Well, the standard form of the equation, when I look at this example right here, the standard form of this one is going to be x minus that x coordinate, which is 1, quantity squared, and then plus y squared, y minus 0, because that's where the y coordinate center is equal to the radius squared. Radius squared is going to be 1. That's the standard form of the equation. I guess I can't get away without telling you the general form of the equation. The general form of the equation is when you get rid of these parentheses and then set it equal to 0, so that this is going to be x squared, and I'll show this to you more in depth, but x squared minus or plus y squared minus 2x, and then minus plus 1 minus is equal to 0. So there, that would be the general form. When you graph this is really what I wanted to show you. You're going to pick this circle tool right here. You click where the center is. In this case, the center is at 1, 0. From there, you can make your circle as big or small as you want. We wanted the radius to be 1. So if from 1, 0 to 2, 0 would have a radius of 1. Once I put that one other point there, it's going to save this, and then I can check my answer. And it would be on to the next question. So back to this. This one right here was the one that I just showed you. So then let's go ahead. Let's see if with this equation we can find the stuff that it's asking for. So find the center, HK, and radius r of the circle. Well, something that's a little bit different about this one is it has 3's in front here, and the equation of a circle, we can't have those there. So what we're going to do, we're going to divide both sides by 3. Fortunately, this 3 is the same both places, and then this side by 3. So when we divide this side by 3, those 3's cancel out, and we're left with x plus 1 squared plus y minus 1 squared is equal to 2. Now you might ask yourself, what if these numbers were not the same? Well, keep that thought in the back of your head to find out later. Here, the center is the opposite of this, so minus 1, and the opposite of this one, plus 1. There's the center. Radius, this graph, this is the radius squared, so if we want to know the radius, it has to be the square root of this number. So square root of 2 is the radius. Graph the circle, find the intercepts, if any. In this case, when we graph the circle, a center, -1, +1 would be right there. All the points are the square root of 2 away. So I went back 1, up 1, back 1, up 1. This length right here to the origin is actually the square root of 2. So if I went over 1 and up 1, I'd have another square root of 2. And if I went down 1, over 1, another square root of 2, up 1, over 1, another square root of 2. Connect those dots like that, and I actually already have the intercepts. Well, maybe it's not always going to be that easy to see. So if it's not quite that easy to see and I have to find the intercepts, the x-intercepts are where it's neither up nor down, so y is equal to 0. If I go back to my equation here and I plug y equal to 0 in, we get x plus 1 squared plus 0 minus 1 squared is equal to 2. I'm going to go through and do some solving for this. We have x squared plus 2x plus 1 plus 0 minus 1, negative 1 squared is plus 1 is equal to 2. So x squared plus 2x plus 2 is equal to 2. X squared plus 2x is equal to 0. When I do some of this in my head, I'm going to factor. So we're going to get x times x plus 2. This one, x is going to have to equal 0. And this one, factor, x is going to have to equal negative 2. So my x-intercepts are at 0, 0, and at negative 2, 0. And those 2 points, 0, 0 is right there, negative 2, 0 is right there. So those are my two x-intercepts. My two y-intercepts, if there are two of them, are going to be where x is equal to 0 because it's neither left nor right. So if x is equal to 0 in this equation, we'd have 0 plus 1 squared plus y minus 1 squared is equal to 2. What y value would make that happen? This is where 1 plus y squared minus 2y plus 1 is equal to 2. So y squared plus minus 2y plus 2 is equal to 2. Y squared minus 2y is equal to 0. It's basically the same problem as before. Solving for y, this one y is going to have to equal 0, and this one y is going to have to equal 2. So my two y-intercepts are 0, 0. We have the same x and y-intercept there. And then 0, positive 2, which is this point right there. The general form of the equation of a circle, I kind of alluded this to before, but it's where you multiply everything out and then set it equal to 0. That would be the general form of the equation of a circle, is when it's all multiplied out and then set equal to 0. So if we see this equation here, this equation is in general form, so it's all multiplied out and it's set equal to 0, but this form here, where it's all multiplied out and set equal to 0, really isn't that helpful for finding the center and the radius. We would want to get it into standard form first. So I'm going to collect the x's. We have x squared plus 4x, and collect the y's. Plus y squared plus 2y is equal. I'm just going to get this 20 onto the other side. Now here, to figure out what the general form is, I'm going to have to complete this square, which is half of the 4. 2 squared is plus 4. If I add 4 to one side, I have to add it to the other side. Complete this square, half of the 2 is 1, squared would be plus 1. Do it to one side, I have to do it to the other side. Now these, I completed the square, so I can write this as x squared, or x plus 2 quantity squared plus y plus 1 quantity squared is equal to 25 when I add those up. Now I have it in the what's called the standard form. I can know now that the center is opposite of this, minus 2, opposite of this, minus 1. There's my center. Radius for this equation is this radius squared is 25, so the radius must be the square root of 25, or 5 is the radius. Graph the circle. Well, we know when we're doing this on MyMathLab, we would click on the center, which is negative 2, negative 1, it's right about there, and then just go 5 units over. Once you go 5 units over on MyMathLab, so if we go about 5 units over, it's automatically going to make the circle for you, and it will make it a lot better than I can freehand it there. The intercepts for the x-intercept, that's where y is going to equal 0. So in this equation right here, when y is 0, we'd have x plus 2 quantity squared plus 0 plus 1 squared is equal to 25, or x plus 2 squared plus 1 is equal to 25. So x plus 2 is going to equal 24. Square root this. We'd have x plus 2 is equal to plus or minus, when we take the square root of 24, we are going to get 2 square roots of 6. If you need to do a little work off your side of your paper, you can. So we get x is equal to negative 2 plus or minus 2 square roots of 6. Our x-intercepts then are negative 2 plus 2 square root of 6, 0. And negative 2 minus 2 square roots of 6, 0. Those are our x-intercepts. Our y-intercept is where it's neither up nor down, so x, or neither left nor right, so x is equal to 0. For our y-intercept, we go back here. If x is 0, we're going to have 0 plus 2 squared plus y plus 1 squared is equal to 25. This right here would be 4 eventually, so I'll just do that. 4 plus this quantity squared is y squared plus 2y plus 1 is equal to 25. I have 4 plus 1, so I'm going to subtract 5 from both sides of the equation. I'm going to get y squared plus 2y is equal to 20. Let's see. I think I want to back up and do this quadratic just a little bit different. Because I already basically had completed the square here. So here we have 4 plus y plus 1 squared is equal to 25. So that's going to be y plus 1 squared is equal to 21. Square root this, we get y plus 1 is equal to plus or minus the square root of 21. So y is equal to 1 plus or minus the square root of 21. Our y-intercepts then are 0, 1 plus square root of 21, and 0, 1 minus square root of 21 for our intercepts. This one here, same thing, except this one just has a fraction. Find the center and radius. Well, before we can do that, we're going to have to write this equation in standard form. So I'm going to collect the x's. X squared plus x plus y squared, collect the y's, plus y is equal, I'm just going to move the 1/2 over to the other side right away. To complete this square, half of 1 is a half, squared is 1/4. So if I add 1/4 to this side, I have to do it to the other side. Same thing here, half of 1 is a half, squared is 1/4. So I'm going to have to move it over to the other side. Here, I've completed the square. This is x plus 1/2 quantity squared plus y plus 1/2 quantity squared is equal to, over here, 1. The center is at negative 1/2, negative 1/2. It's the opposite of these here. The radius is the square root of this, which is the square root of 1 is just 1. Graphing it on MyMathLab, again, what you would have to do, first you would have to click the center spot. So you go over, you click that spot, and then go over a radius of 1 to there. It's going to automatically populate the rest of the circle for you. Finding the intercepts, well, again, x-intercept is neither up nor down, so y is going to be 0. If I plug that into this equation right here, we get x plus 1/2 squared is plus 0 plus 1/2 squared is equal to 1. So x plus 1/2 quantity squared plus 1/4 is equal to 1. Subtract 1/4 from both sides and we're going to get x plus 1/2 squared is equal to 3/4. When I square root this on both sides, I'm going to get x plus 1/2 is equal to plus or minus square root of 3 over 2. And so we get x is equal to 1 plus or minus square root of 3 over 2. So my x-intercepts are at 1 plus square root of 3 over 2, 0, and 1 minus square root of 3 over 2, 0. The y-intercepts are where it's neither left nor right, so x is going to be 0. I plug that into here, so I plug the 0 in, 0 plus 1/2 squared plus y plus 1/2 squared is equal to 1. Well, this is actually almost identical to this right here. So I know that when I go through and solve this, all said and done, I'm going to get the same here except y. So y is equal to 1 plus or minus square root of 3 over 2. My two y-intercepts are at 0, 1 plus square root of 3 over 2, and 0, 1 minus square root of 3 over 2. There's my y-intercepts and my x-intercepts. Good luck! The next section will be if we don't end up with a perfect circle.